Hello everybody, my name is Yujin. I feel extremely honored to have this opportunity to make my presentation here today. I'm going to talk about a study on interaction latency in AR-based collaborative system. Here is my content. The first part is introduction. In this part, I will introduce the research background. The first point is remote collaborative system. COVID-19 has recently become a worldwide pandemic. Because of that, the demand of remote collaborative systems is increased. One of the most popular remote collaborative systems is video conferencing system. The second point is recent researches. The video conferencing system is user-friendly because it is a conventional system, but it has limitations in immersion and work efficiency. To overcome it, research to apply virtual reality or augmented reality to remote collaborative systems has been recently conducted. But if applied VR or AR, then because of the technical characteristics, latencies can be issued. The third point is AR-based collaborative system. In remote collaborative system based on virtual reality or augmented reality, following latencies may occur: rendering latency, measurement latency, registration latency, network latency, or etc. Latencies like above can impair not only users' interaction satisfaction, but also work efficiency. So, studies on influence of latencies are required. But, unlike VR, in case of AR, studies on latency is insufficient. Therefore, in this study, we study on the effect of interaction latency in AR-based collaborative system. Turning now to second part. The second part is a brief overview of related works. In this part, I will introduce AR-based collaborative system in brief. The first point is feature. The AR-based remote collaborative system is highly influenced by the quality of registration when interacting with virtual objects due to the nature of the technology. And one of the factors that most affects the quality of registration is latency. The second point is latency. Examples of the latencies in AR-based remote collaborative systems are as follows. First, interaction time that users pass their intention. Second, sensing time that sensors measure and process the environment. Third, rendering time that object orientation and position are processed and object is rendered. Fourth, sending time that system sends data to other users in the remote location through the network. Fifth, receiving time that system receives data from the remote user through the network. In this study, experiments were conducted by applying an additional latency to include all of them. Moving on now to third part. The third part is experimental research and discussion. In this part, I will introduce environment, variables, and two conducted experiments and their research in this study. First section is environment and the first point is subject. The subjects of this study are young adults in their 20s or 30s who are currently attending the university. All subjects were disease-free and were advised to take adequate rest before the experiment. All subjects completed the experimental consent form before the experiment. Second point is experiment environment. Experiment environment is as figured in the screen. Subject will wear HoloLens 2 like experimental view in figure. And then subject can see virtual hand augmented on their hands and virtual objects like sphere on subject view in figure. Third point is experiment procedure. Quantitative factors such as completion time and distance to target are measured during subject to task as below figure with respect to various latencies. Subject task consists of two steps. The first step is object moving step. In this step, subject should move manipulation object to the position of the target object. The second step is object scaling step. In this step, subject should scale the manipulation object to fit the scale of the target object. I want to turn now to second section. The second section is variables. There are three main variables. The first variable is additional latency. Additional latency is an independent variable that any additional latency conditions given during interaction. The second variable is completion time. Completion time is a dependent variable that time until subject completes task. The third variable is distance. Distance is also a dependent variable that the distance between the object moved by subject and the target. The next section is in regards to first experiment. First point is condition. In first experiment, latency effect of 0 milliseconds to 200 milliseconds with 50 milliseconds increased was examined. This condition is referenced to the condition of conventional virtual reality studies. Second point is research. The research of the cross-wallis test, a non-parametric test, is shown in the following figure. No significant latency effect was found under the latency condition of first experiment. Unlike augmented reality, virtual reality requires rendering not only virtual objects but also backgrounds. Therefore, we guessed virtual reality is more sensitive to the influence of latency than augmented reality. The final section in this part is second experiment. First point is condition. In second experiment, latency effect of 0 milliseconds to 800 milliseconds with 200 milliseconds increased was examined. This condition is referenced to the condition and research of the first experiment. Second point is research. The result of the cross-wireless test, a non-parametric test, is shown in the following figure. Significant difference was found in distance to target and completion time under the latency condition of second experiment. Specifically, distance to target in 600 milliseconds, significance level 0.015, 800 milliseconds, significance level 0.000, and completion time 800 milliseconds, significance level was now. I'd like to move on to fourth part. Fourth part is conclusion. To summarize the main point of my presentation, in this study, we analyzed the effect of latency on interaction for an AR-based collaborative system through quantitative factors. From the research of experiments, it was confirmed that latency in AR-based collaborative systems should be lower than 600 milliseconds. We hope our research provides a guide about latency to researchers and developers of AR-based collaborative systems. This study has difficulties in recruiting test subjects due to COVID-19, which is spreading as a global pandemic, despite the importance of test subject participation. In this study, we tried to secure the minimum number of people who could secure statistical significance by providing appropriate compensation to the study subjects. However, non-parametric statistics were performed because of a sample with guaranteed normality was not secured. So, in the future, we will try to secure the minimum number of people who could secure statistical significance. Thank you for listening. I hope you found it interesting.